In this lesson, we are going to learn about DeltaStar Transformation. So sometimes you see that you'll be given a question and then you can't tell whether the resistors are in a series connection or they are in what? A parallel connection. So when this happens, that's when what we apply the DeltaStar transformation. When I say resistors are connected in a delta form, let's look at what that means. Okay, so when resistors are connected in a delta form, this is what it means. So this is how the connection will be. Okay, some connection of this form. So this is a delta connection. Okay, this is a delta connection. And then it can also be in this form. It can also be in this form. Okay, so this is also a different form of what? Delta connection. It is known as what? The pi network. Okay, so if you don't see the delta and you see the pi, it is the same thing. Okay, and then you have what? The star connection also. Okay, so for the star connection, it can be in this form. It can be in this form, something like this, or it can be in this form, or it can be like this. Okay, so this one is what? A star network. Okay, so that's star network. Okay, so we apply this method. Okay, when you can't tell whether resistors are in a series connection or what are in a parallel connection. So let's look at how you are going to apply the delta star transformation. So let's say we have a resistor connection in a delta form. Okay, you have it in a delta form and then you want to change it to star. So that's what you are changing from delta network to what? To star network. So to do this, we have the connection drawn in the blue color to be the star network and then the one drawn in the white to be what? The delta network. So to change from delta to star, you're going to use this formula. Okay. So to do this, I'm going to calculate for the first star value, okay, which will be what? R1. Okay, so in that case, R1 will be equal to RB times what? RC. Okay, so you're going to multiply the value of what? The two delta resistors, okay, on the left and the right side of what? R1. So that what? RB times what? RC times RC. Okay, then all divided by what? The sum of the what? The resistance value in the what? In the delta connection. Okay, so that what? Divided by RA plus RB plus what? RC. Okay, so to do same for R2 also. So R2 will be equal to what? The product of the resistors on the left and then the right side, which will be what? RA and then RC. So that what? RA multiply what? RC. Okay, divided by the sum, which will be what? RA plus RB plus RC. Okay, and then we are going to do the same for the third resistor in the star network, which will be R3. So we are going to multiply RA and then RB. Okay, so that what? RA times RB. Okay, divided by the total, which will be RA plus RB plus what? RC. So this is what. So you use this formula when you are changing from a delta network to what? A star network. So let's write this down so that we continue with what? Changing from star to delta. So I'll go ahead and then clean this here. Okay, so now let's say you are changing from a star network, to a delta network. Okay, so in this case uh, we are having a star network. Okay, but I want to change it into what? Into a delta network. So before then, what you have to do is that let's multiply the values of what? The star network. So I'm going to multiply R1 by what? R2. So that was R1 multiplying R2. Okay, then I multiply R2 by R3. That was plus R2 multiplying what? R3. And then finally I'll multiply what? R3 and then R1. So that was R3 multiplying what? R1. Okay. So I'm going to use this in all the formulas that we are going to use for star to delta transformation. So let's look at that. So to calculate for RA here, okay, RA okay will be equal to this sum that we have derived here. So that will be equal to what? R1 multiplying R2, okay, plus R2 multiplying what? R3, okay, plus R3 multiplying what? R1. So we then divide all by what? The value opposite to what? RA, which is what? R1. So all divided by what? R1. Very simple. So let's do same for RB. So for RB also, we are going to use the same sum that we derived here. Okay, so that was R1 multiplying R2 plus R2 multiplying what? R3 and then plus R3 multiplying what? R1. So all this divided by the value opposite to what? RB, which is what? R2. So all this divided by what? R2. Okay, so this is for what? The second resistor in the delta connection. So let's do same for the third resistor, which is what? RC. Okay, so to calculate for RC also, this will be equal to what? R1 multiplying R2 plus R2 multiplying R3 plus R3 multiplying what? R1. Okay, so all this divided by the value opposite to what? RC, which is what? R3. So we use this formula when we want to change a star network to what? A delta network. Okay, so with this understanding, let's try our hands on an example. Okay, so with this example, we have to determine the voltage V0 across the 6 ohms resistor. Okay, so to determine the voltage across this 6 ohms resistor. So when you look at this circuit here, you see that what now the resistors are in a series connection or what are in a parallel connection. So therefore, we are going to apply what the delta star transformation here. So looking at this, okay, when you look at this side, you see that what considering this three okay resistors here, you see that what we have what a delta connection here. Okay, you see that what we have a delta connection here, and then when you look at this three also, you see that what we have what a star connection here, and then looking at these three also, we have what a tie connection here. So depending on the one that you want to use, you can choose one of them. Okay, the one that will be easy for you. So I'm going to consider this delta network here. Okay, so saying this is a delta network, before I'll be able to calculate for the effective resistance, I have to change it to what? Into star network. And when I change it from delta to star, it will be easy for us to calculate for the effective resistance. So I'm going to redraw this circuit here. Okay, so let's look at how I'm going to do it. So I have the 6 ohms resistor here. Okay, I have the 6 ohms resistor here. Okay, so now that I have this 6 ohms resistor, I'm going to draw this 2 ohms resistor and this 2 ohms also. So I have this 2 ohms resistor here. Okay, this is 2 ohms. Let me write it here. I have these 2 ohms here, so I'm going to draw these 2 ohms also. Okay, so this is another 2 ohms resistor. Okay, this is another 2 ohms resistor. And then so you see that what we have this 6 ohms and then these 2 ohms resistors. So now I will draw these 2 ohms resistor here. So that will be here. Okay, so this is what the 2 ohms resistor. And then I have this 6 ohms resistor. So this is the 6 ohms resistor. So now I come and draw the voltage source, which is the 10 volt voltage source. Okay, so this is the 10 volts voltage source. So you see that what I've retransformed the circuit into a very simple way. Okay, so now let's look at what you are going to do here. Okay, let me write these 2 ohms here outside. Okay, so I have the 2 ohms here. So what happens here is that I'm going to change this uh, delta network here to a star network. Okay, so now let's look at how you're going to do that. So I have one resistor here, and then I have another one here, one resistor here. Okay, then I have another one here, and then I have another resistor here also. Okay, so that's the star connection that I have drawn in this. Okay, so I'll name this as RA. Okay, then I'll name this as RB. Let me write it here. Okay, then I'll name this as what? RC. Let me write it here. Okay, so now you've drawn the star connection in what? In this delta connection here. Okay, so now you know that what you are converting from what? You are converting from a delta to what? A star network. Okay, you are converting from what? A delta to a star network. So now let's look at how we are going to do it. Okay, so to do this, to find RA, okay, RA will be equal to what? RA will be equal to what? These 2 ohms resistor times what? These 2 ohms resistor. So that what? 2 times 2. Okay. Divided by the sum of all the resistors. That what? 2 plus 2 plus 6. That will be divided by 2 plus 2 plus 6. Okay. Because we are converting from what? A delta to what? A star network. So that will be 4 divided by 10. And that will be equal to what? 2 over 5 ohms, which is equal to 0.4 ohms. Okay, that's in one decimal place. Okay, so now let's do same for RB. Okay, so RB also, when I take RB, I'll multiply these 2 ohms here by this 6 ohms here. Okay, so that what? 2 times 6. Okay, divided by the total, which is what? 2 plus 2 plus 6. Okay, so this will be 12 divided by 10. Okay, which will be equal to what? 1.2 ohms. Okay, so now let's do same for the third resistor, which is what? RC. So RC also, I'll multiply this 6 ohms by these 2 ohms here. Okay, so that will be 6 times 2. Okay, so that was 6 times 2 divided by what? 2 plus 2 plus 6. That will be 12 divided by 10, and that will be equal to what? 1.2 ohms. So now we've converted it from what? The delta network to what? To the star network. So now let's look at how our circuit will be now. So let me clean all this. So now I'm going to redraw the circuit, and then instead of using a delta network, I'm going to use what? The star network. Okay. So this is the circuit now. Let me redraw this resistor again. Then I have this resistor here again, and then I have another resistor here also again. Okay, so with this, I have this 6 ohms resistor here. Okay, then finally we have what the voltage source here. So this is a 10 volt source, and then this will be RA. Okay, this is what RA, which you got to what 0.4 ohms. Okay, and then this is the 6 ohms resistor, and then this is what a 2 ohms resistor, and then I have here to go what RC, okay, which is what 1.2 ohms, and then I have here to go what RB, which is what 1.2 ohms. Okay, so this will be the circuit now. So now let's write down the values. We know RA to be equal to 0.4 ohms, and then we know RB to be equal to what 1.2 ohms, and then RC to also be equal to 1.2 ohms. Okay, so now let's continue and then simplify the circuit. So now after doing this, you can see that what we now have what series and then parallel connection in the circuit. Very simple. So now let's continue. So you see that what this 1.2 ohms here, then this is ohms resistor here what are in a series connection, and also this 0.4 and then these 2 ohms here what are also in a series connection. I'm going to add these two values, and I'll add these two values also. So that what 1.2 plus 6, and this will be equal to what 7.2 ohms, and then 0.4 plus 2, this will be equal to what 2.4 ohms. So instead of using these two resistors here, I'm going to use 7.2 ohms resistor, and then instead of using the 0.5 and the 2 ohms, I'll use what the 2.4 ohms resistor. So now let's redraw the circuit. So I have the circuit now to be something like this. Okay, then I have another resistor here. Okay, then I have the voltage source here. Okay, let me draw this. This is a 10 volt source. Then I have this 1.2 ohms here. Then I have this side board 2.4 ohms. And then I have what the 7.2 ohms here. So now we have a very simple circuit here. Okay, so with this you can see that the 2.4 ohms and then the 7.2 ohms resistors are what in a parallel connection. So the 2.4 resistor is in parallel connection to the 7.2. So this will be equal to 2.4 times 7.2 divided by 2.4 plus what 7.2. So let's see the value of this. That will be 2.4 times 7.2 divided by 2.4 plus 7.2. So this will give me a value of what 1.8 ohms. Okay, that was 1.8 ohms, and then this will be in a series connection to the 1.2 ohms resistor. So that was 1.8 plus 1.2. Okay, and this will be equal to what 3 ohms. So now you have the what effective resistance to be equal to what 3 ohms. So now that you know the effective resistance, you can calculate for the current in the what in the circuit. So let's look at how you are going to do that. So we can use what Ohm's law, which is what voltage equals what the product of current and then resistance. And we know resistance to be 3, and then we know voltage in the source to be what 10. So we have what the current to be equal to voltage over resistance, which will be what 10 divided by what 3. And this will give me what 3.3 repeating. So that was 3.3 repeating. So that's what the current in this circuit. Okay, so you see that this current will be coming from the source here. Okay, so let's name this current I, and then some will branch into this branch, and then some will also go here. So let's name this I1, and then let's name this what I2. Okay, so now what we will need here is that since you want to calculate for the current in this 6 ohms resistor. Okay, and we know that what we added this 6 ohms and then the 1.2 together with the 7.2 ohms. So our main focus will be on the current flowing through this resistor here. Okay, so our main focus will be on the current flowing through this resistor here, which is what the I2 here. So we're going to find this I2. So to do this, we can apply our current division here. Okay, so I2 will be equal to the total current, okay, which is what 0.3 amperes times what this resistance value here, which is what 2.4 ohms divided by the sum of these two resistance values, that what 2.4 plus 7.2. So this will be equal to 3.33 times 2.4 divided by 2.4 plus 7.2. So this will give me the current I2 to be equal to what 0.8383 amperes. Okay, so this is the current flowing through this branch or flowing through this resistor here, and then that's the current that we need. So from here, you know that what we added the 6 ohms resistor and the 1.2 ohms resistor to get this 7.2 here. Okay, this is because they are in what in a series connection. So you can change it back from this form here, okay, to what we have here. Okay, so now you know that what they are in a series, that's why we added them. Okay, so you can still split them. So when we split them, what that means is that this current I2 here, okay, will flow through the 1.2 ohms resistor, and then that same current will flow through this 6 ohms resistor here, since they are in what in a series connection. So now we know the current flowing through this 6 ohms resistor to what 0.833 amperes. We can now calculate for the voltage across of this resistor. So you know that what voltage equals what current times what resistance. So therefore V naught will be equal to what I2 times what the 6 ohms resistor. Okay, this is because this current I2 is flowing through this branch here. Okay, that will pass through this 7.2 ohms resistor, and this 7.2 ohms resistor is same as what this 1.2 ohms and then this 6 ohms separated. Okay, so we now know the current flowing through this 6 ohms resistor to be 0.833 amperes. So that was times what 6. So 0.833 times 6, so that was 4.998. That was sorry 4.998 volts. That would be equivalent to 5 volts. Therefore, the voltage across the 6 ohms resistor will be 5 volts. So this is how to apply the delta star transformation in solving a question. So if you want to change from delta to star, you have a formula to use, and then if you want to change from star to delta, you also have a formula to use. Please take note of that. Thank you very much for watching this video.